Math 3, Unit 7, Whiteboard Review. Number 1, what is the formal definition of a circle? So a circle is the set of all points equidistant from a given point. Okay, so the given point is your center, and all of the points are equidistant, are what make up the circle. The distance between every single point on the circle and the center is the radius, and that the radius is the same around the entire circle. The formal definition of a parabola is the set of all points equidistant from a given point and a line. So what we're talking about there, the point they're talking about is the focus. The line they're talking about is the directrix. And all the points on the parabola are equidistant from both the focus and the directrix. And so that definition is your parabola. All right, for 3 and 4, both of these are the same type of questions. We're going to go ahead and find vertex, focus, directrix, and focal chord endpoints. First thing is we want to get this into our vertex or directrix form. So I'm going to divide by -8 to both sides. When I do that now, I have -1/8 y plus 2 squared equals x minus 3. When you only have one squared term, you want to get the term that isn't squared by itself. And so I want to get x by itself, and I would do that now by adding 3 to both sides. And so now that I have x by itself, I'm going to go and flip this around, and we'll write this as x equals -1/8 y plus 2 squared plus 3. And so this is my equation. From there now I can find the vertex. My vertex, we always set this equal to 0. When I do that, I find that y equals -2. So for my vertex, the y value is -2, which means this value is for my x. The next thing that I'm going to think about is the direction of my vertex. Since this is x equals, the direction of my vertex would be curving right or curving left. And then again, because this is negative, we know for sure my graph is going to curve to the left. I'm going to go ahead and plot my point, 3, -2. And I'm going to label that with a V to remind me it's a vertex. In order to get my focus and my directrix, we are going to use our formula, which is 4c equals the reciprocal here, which we're going to write as 8. You could also write that as -8, either way. Divide by 4 to both sides, and I find that c is 2. So what that tells me is that because my graph is going left, I'm going to go 2 to the left for my focus value and 2 to the right for my directrix. Next, whatever this value is, we multiply it by 2. So 2 times 2 equals 4. 4 is the distance I go from my focus to the right and to the left. So we're going 1, 2, 3, 4 to the right, and 1, 2, 3, 4 to the left. And we can go ahead and draw our parabola now. Also remember this distance here is also the reciprocal of this value, and so which would give you 8. The whole distance here is 8. So we have our vertex. My focus, the ordered pair for my focus, which is right here, is at 1, -2. My directrix is this line right here, which is x equals 5. And then my focal chord endpoints are these endpoints right here. And so one of those points is at 1, 2, and the other point is at 1, -6. All right, same type of problem. But this time my squared term is actually an x, where the previous one, the y squared, the squared term was y. And so we're going to start by dividing by -2 to both sides. So those eliminate. I bring that out, and I have -1/2 x minus 3 squared equals y plus 1. We need to get y by itself, and so I will subtract 1 to both sides, and these eliminate. Now that I have y by itself, I'm going to flip that around, and I get y equals negative 1/2 x minus 3 squared minus 1. So here's my equation. Based on my equation there, my vertex, I would set this equal to 0, and I'd end up getting x equals 3, so we know 3 goes in the x spot, and negative 1 would then go in the y spot. Next, I can go ahead and graph that, and so 3, negative 1, I'm going to go right 1, 2, 3, down 1, and label that with a V for my vertex. This graph, it has y equals, so I know it'll either go up or down, and then it's going to specifically go down because it's a negative value. So we know this graph is going to go down. To find the distance that I go there, for my focus in Directrix, I go 4c equals this reciprocal, which is 2. And then I divide by 4 to both sides to get c by itself, and I get c equals 1/2 or 0.5. Because the graph is going down for my focus, I go 1/2 down for my focus and 1/2 up for my Directrix. My focal chord endpoints, I multiply that by 2 or double it, and when I do that, I end up getting 1. So for my focal chord endpoints, I'm going to go to the right one and then to the left one. And then I'm able to draw my curve there. The point that the focus is at 3, and it goes down negative 1 and 1/2. The Directrix went up 1/2 from there, and so my Directrix is through the line, y equals negative 1/2. My focal chord endpoints, they go out here, and that is at 4 and negative 1/2, and then the other one is at 2 and negative 1.5. You could also put those as 0.5, either way, that works. Number 5, find the center and the radius. Okay, so this, because we have 2 squared terms, we know it's a circle. I'm going to put all my x's together. I have x squared plus 8x plus blank. I would go through and cross out what I've used. Plus, we're going to put all of our y terms together. So I have y squared. There's no other y terms, so I don't have to complete the square for y squared. Equals this negative 20, when we move it to the other side, it becomes a positive 20. And to make this a balanced equation, if I have 1 blank on this side, I need 1 blank on the other side to make it so it's balanced. To complete the square, I'm going to go 8 divided by 2, which is 4, and 4 squared is 16. 16 goes into my blanks. This factors to be a perfect square, which is x plus 4 squared. 4 plus 4 makes 8. 4 times 4 makes 16. I have plus y squared equals, and then 20 plus 16 is 36. Now that I have my equation, my center, we set this equal to 0, and that would give me x equals negative 4. There is no parentheses. There's nothing with the y that can be added or subtracted, and so the y value is 0. And then for my radius, it is always the square root of this value. And the square root of 36 is 6. Same thing here, we're going to find the center and the radius. So I'm going to start with my x's, and I have x squared plus 6x plus blank. I'm going to cross out all my x's. Plus, next I have my y's, so I have y squared minus 2y plus blank equals this negative 15, we move it to the other side, it becomes a positive 15. Since I have 2 blanks here, I'm going to need 2 blanks on the other side. We're next going to complete the square. I take 6 divided by 2, which is 3. 3 squared is 9. Negative 2 divided by 2 equals negative 1, and negative 1 squared is 1. Now to write our equation, this factors to be x plus 3 squared plus my y's factor to be y minus 1 squared equals, we add all of that together and it equals 25. So with that information now, my center, we set this equal to 0, and we would get x equals -3. We set this equal to 0, we would get y equals a +1. And for my radius, I would take the square root of 25, which is 5. Okay, let's go ahead and move on to the next page. Okay, for these problems, we just need to write the equation in focal width form or a variation of vertex descriptive form. This is what I'm going to be doing. Okay, and so in order to get this into the correct form, we always want to get rid of the coefficient that's in front by factoring it out. And so I am going to go ahead and factor out a 1/2. When I do that, I'm dividing each of these by 1/2. So 1/2 divided by 1/2 cancels out. I have x squared. What this is saying right here is -4 divided by 1/2. Okay? With fractions, we always do the keep it the same, change it to division, and flip it. And so this would change to be -4/1, change division to multiplication, and flip this to 2/1. When you multiply that, you get -8/1, which is just -8. So -4 divided by 1/2 is -8. -8x. We're going to complete the square, so we do plus our blank. This time the 3, because it doesn't have any x's with it, we put it on the outside here. And because we're keeping our blank on the same side of the equation, this is saying 1/2 times the blank. In order to balance it, it needs to be the opposite. So if this is a +1/2, this is -1/2 times the blank. So we're going to add and subtract the same numbers so that it's balanced. -8 now divided by 2 is -4, and -4 squared is 16. So 16 goes into each of those blanks. We now will write our equation, which is y equals 1/2 x minus 4 squared. And we simplify this. Right here, two fractions being multiplied. -1 times 16 is a -16 over 2 times 1, which is 2. And -16 over 2 is -8. So I have 3 minus 8, which is -5. So -5 goes here at the end. And we have it written in the correct form. Number 8, we're going to do the same thing. Again, we always want to factor out the coefficient that's in front of our squared term. So I have x equals, I'm going to factor out a 4, which means I'm dividing each of these terms here by 4. When I do that, the 4's cancel out, and I have y squared. 16 divided by 4 is 4y plus blank. The 45 goes on the outside. And again here, since I have 4 times the blank, I need -4 times the blank. To complete the square now, I take 4 divided by 2, which is 2, and 2 squared is 4. So 4 goes into each of these blanks. Now we will write our equation. I have x equals 4, parenthesis, y minus 2 squared. And then here we have 45 minus, and 4 times 4 is 16. 45 minus 16 is 29. So we end up with plus 29 at the end, and that is my equation. Okay, for writing the equation of a circle with this at the center and this being our radius, the equation for a circle is x minus h squared plus y minus k squared equals r squared. And so all we're doing is putting this information in here. H and k represent numbers. And so in this case, my center would be h comma k, and the radius would just be r. Okay, so plugging this information in here, you would have x minus a -2 squared, which makes it a plus 2, plus y minus 5 squared equals, and then this is the radius, but we know that that has to be squared. And so we need to square that. So 3 squared is 9, and root 2 squared is 2, and 9 times 2 is 18. So my equation ends up being x plus 2 squared plus y minus 5 squared equals 18. Number 10, write the equation of this circle. So it's the same exact concept. We're using that same exact formula. Okay, so on this one, we would end up with x minus 4 squared. And again, if you set this equal to 0, you'd get your positive 4. Plus y minus a negative 6 squared, which we know two negatives side by side like that make a positive, equals 2 root 5 squared. We would then simplify this. 2 squared is 4, and when you square root 5, you get 5, and 4 times 5 is 20. So my equation is x minus 4 squared plus y plus 6 squared equals 20. All right, this next problem, number 11, we are going to use the distance formula. The distance formula is the square root of x1 minus x2 squared, or it could be x2 minus x1 squared, plus y1 minus y2 squared. And it's the square root of that. So we are using our distance formula to write the definition of the parabola with a focus at 3, 0 and a directrix at y equals 4. And so we know from our formal definition of a parabola that a point to the focus has an equal distance as a point to the directrix. They both have the same distance. And so we can write our equation or derive it based on this information. The point we use is xy, and in this case our focus here is 3, 0, and then the point we use is xy. And the directrix, since it's y equals 4, we put 4 in at the y spot, and then just x at the x spot. We will now use our distance formula. So we have this square root, and we'll subtract x minus 3 squared plus y minus 0 squared equals, over here we have our square root, x minus x squared plus y minus 4 squared. So now we'll go through and simplify. We end up with x minus 3 squared plus y minus 0 is just y squared equals, over here x minus x is 0, and so that cancels out, and we just have y minus 4 squared. Next, we'll eliminate our square roots, and you do that by squaring both sides. So we square both sides. I'm left with x minus 3 squared plus y squared equals y minus 4 squared. Looking at these, anything that is the same we want to multiply out so that we can combine like terms. And so if you look, you should notice that we have these are y's and these are also y's. And so I want to end up combining them together. So I don't have anything to multiply out with this y squared. So when I rewrite this, I have x minus 3 squared plus y squared equals, and I'm going to multiply out y minus 4 squared. You can do that using the distributive method, or if you're able to do this in your head, you can multiply it out that way. When you multiply it out, you get y squared minus 8y plus 16. Okay, looking at this now, you can see that there's a y squared on both sides, so we can eliminate those. Now I just have x minus 3 squared equals negative 8y plus 16. We want to get y by itself, so I will subtract 16 to both sides. I have x minus 3 squared minus 16 equals negative 8y. And the last thing I would do to get y by itself is divide by negative 8 to every single term. When I do that, I now have y by itself, and so y equals negative 1/8 x minus 3 squared, and negative 16 divided by negative 8 makes a positive 2. And so that is my equation for a parabola with a focus at 3, 0 and a directrix at y equals 2. Okay, we'll go ahead and do another one like that. So same thing, where we know that from the point to a focus and the point to the directrix, it's the same distance. So PF equals PD. The point we will use is XY. My focus is at -4, 3. Again, my point is XY. This time my directrix is at X equals -6, so -6 goes in the X spot, and then Y goes in the Y spot. We'll now use the distance formula to find that. And so we take X minus a -4 squared plus Y minus 3 squared equals, the distance formula over here is going to be X minus a -6 squared plus Y minus Y squared. So if we go through and simplify here, we know here 2 negatives make a positive. Over here 2 negatives make a positive. And here Y minus Y cancels out, and that is a 0. Next, in order to eliminate the roots, we would square both sides. So I'm going to go ahead and square both sides. When I do that, I end up with X plus 4 squared plus Y minus 3 squared equals X plus 6 squared. I look for my like terms. You can see here that my like terms are my X's. So we're going to leave the Y's alone, but I'm going to multiply these out because I want to combine all my like terms together. So we multiply out X plus 4 squared, and when I do that, I get X squared plus 8X plus 16. That multiplied out there. Then I have still plus my Y minus 3 squared that I'm leaving alone. And then we multiply this out, and I get X squared plus 12X plus 36. Okay, from there, any like terms that are the same on both sides I can eliminate. So since I have an X squared here and an X squared here, those cancel out. I want to end up getting my X's by themselves. Okay, so there's a lot of ways you can do this. I'm going to go ahead and subtract 8X over here. Okay, and when I do that, I'm going to rewrite this. I have Y minus 3 squared plus 16. I'm just flipping that around because normally that number comes after our squared term, equals, and then here 12X minus 8X is 4X, and then I still have plus 36. So again, I'm trying to get my X's by itself. I'm going to subtract 36 to both sides. When I do that, I have Y minus 3 squared. 16 minus 36 makes a -20 equals 4X. And then last thing, to get X by itself, I would divide by 4 to every single term. And I do that, and I end up with X equals 1/4, because that would be 1/4, Y minus 3 squared minus, and 20 divided by 4 is 5. So that is my equation. All right, number 13, graph this parabola. This isn't quite in the correct form right now. We want to get X by itself, and so I would divide by 2 to both sides. Those eliminate, and I get the equation X equals 1/2 Y squared. Based on this information, we need to first find our vertex in order to graph. And so this vertex, since there's nothing here with the Y value would be 0, and there's nothing adding at the end, so the X value is 0. And so this graph, the vertex, is at 0, 0. Now the direction of this parabola, since it's X equals, we know it's either going to curve left or curve right, and we specifically know it's going to curve right because this value is positive. So we know we are curving to the right. Now, in order to find the focus in the directrix, we use our equation for C equals the reciprocal of 1/2, which is 2. We divide by 4 to both sides, and we get that C equals 1/2 or 0.5. So that tells me my focus is 1/2 to the right, and I label that as the focus. My directrix is 1/2 to the left, so we draw that. We know that to find our focal chord endpoints, it's 2 times 1/2, which will end up giving me 1. So I go 1 in each direction from my focus, and then I can draw my parabola. Based on what I've done, I know that my focus is at 1/2, 0. My directrix is right here at x equals -1/2. And my focal chord endpoints are at 1/2 and up 1, and they're at 1/2 and -1. Okay, we have this next one that we're going to graph. Again, the x is not by itself, and so I'm going to subtract 1 to both sides in order to get the x by itself. So I end up with x equals 1/8 y plus 2 squared minus 1. After this, I know that my vertex, when I set this equal to 0, I get y equals -2, and the y value, because the y value is -2, I know that my x value is at -1. So -1, -2, that is my vertex. The direction of my parabola is going, because it's the x-axis, we know it's going to go either right or left, and we know specifically it's going to the right because this value is positive. To know how far we go for our focus in our directrix, we write 4c equals the reciprocal of 1/8, which is 8. We divide by 4 to both sides, and we get that c equals 2. So my focus always is on the inside of my curve, so I know I'm going to go right 2, and that's my focus. Left 2 is my directrix. My focal chord endpoints is always this value being doubled, so 2 times 2 equals 4. So I'm going to the right 4 and to the left 4. And then we can draw our curves. Also, we know this total length equals the reciprocal value, which is 8. Okay, so based on my information there now, I know that my focus is at 1, -2. My directrix is at x equals -3. And my focal chord endpoints are at 1, 2, and 1, -6. Okay, another parabola we need to graph. It says find the focus, directrix, focal chord endpoints. Here, y is by itself. I don't have to do anything else here. There's no plain x term to complete the square. We just need to graph this. The direction of my graph on this one, because it's y equals, we know it's going to go up or down. And I specifically know it's going to go down because my a value here is negative. So we know this is going down. Based on the information here, my vertex, we know since nothing is being added here in parentheses with the x squared term, we know the x value is 0. The 3 is my y value for the vertex because my x value was with the x squared. So 0 up 3, there is my vertex. From there, we take 4c and set it equal to the reciprocal here, which is 4. We divide by 4 to both sides, and we get that c equals 1. Because this is going down, I know that my focus is going to go down 1, and then my directrix will go up 1. My focal chord endpoints is always this doubled, so 1 times 2 is 2. So my focal chord endpoints, I go 2 in each direction, and then I can draw my curve. So after I have that, we know that our focus is at 0, 2. My directrix is up here at y equals 4. My focal chord endpoints are at 2, 2, and at -2, up 2. Okay, moving on. We're going to go to number 16 where we want to graph a circle. Okay, this circle is already put in the equation for us. We are going to start by finding the center in order to graph it. X plus 2 equals 0. We find that x equals -2. Y plus 3 equals 0. We find that y equals -3. And then for a radius, we know that it's always the square root of that value. The square root of 8 would actually break down to be 2 times 2 times 2. You get a pair of 2's, a 2 left over. So this is the same as 2 root 2. And then specifically, to give us an idea on graphing, it's about 2.8. We know that the square root of 9 is 3. It's almost to the square root of 9, so it's close to 3, but not quite there. When we graph this, we'll go ahead and go -2, -1, 2, 3, and that is our center. We go our radius Okay, so 2.8, this is going out 1, 2.8. And then going up 1, 2.8, 1, 2.8, and down 1, 2.8 to help us make a more accurate circle. So once you have your circle, I'm sure yours looks way better than mine, you're going to be asked some questions. So based on the equation above, negative 3, 4. So they're saying the point, negative 3, negative 1, 2, 3, 4 is inside, wait, did I do that right? Negative, oh, sorry, negative 3, positive 4. So negative 3 up 4 is right there. Forget about that. So looking at that, I think it's pretty obvious that it is outside the circle. So you need to justify your answer. You could say, based on the graph, because we're at this point and this point and it only goes out 3, there's no way it could be way above the x-axis like that. Mathematically, you can show that it's outside the circle by plugging in these values into the equation. And so what I mean by that is, if we go back to our equation that we have right up here, and I go, instead of writing x, I'm going to put negative 3 in for x plus 2 squared, plus for y I'm going to plug in 4, so 4 plus 3 squared. And basically I'm wanting to see, well, what happens to it in terms of 8? If it equals 8, it's on the circle. If this value is greater than 8, it's outside the circle. And if this value is less than 8, it's inside the circle. And so negative 3 plus 2 makes negative 1, and negative 1 squared is 1. Okay? 3 plus 4 is 7. 7 squared is 49. 1 plus 49, well, that's 50. And 50 is definitely greater than 8. And so since it's greater than 8, we know it's outside the circle. Last one says, how many times does a circle above cross the x-axis? So right here you can see that it's not going up to 3. It's not even touching the x-axis. And so for the x-axis, it's 0. It does not ever cross the x-axis. For the y-axis, if you look, it is touching the y-axis 1, 2 places. And so it intersects the y-axis 2 times.